So two definitions to review and write down, right? Symmetry, we've got rotation symmetry. If you turn an object around a point and it matches up again, then it has rotation symmetry. And then line symmetry, if you flip an object over a line and it's the same on the other side, then it has line symmetry. We can take a shape and do something called a transformation, which means we can reflect it or translate it or move it so that it either has line symmetry, rotational symmetry, both rotational and line symmetry, or no symmetry at all. So here's an example. Okay? This shape, can you see that the shaded shape has been copied, and then what we call this in this situation where you take it and slide it, we call that a translation. So when you slide an object from one spot to another, it's a translation. Is this line symmetry? Okay, if I reflect it over this line here, does it match up perfectly? No, because it would have the point the other way. Okay? This one, though, after it's done, if we drew the line this way, it could have line symmetry that way. Remember the diagonal ones we called oblique. Can you see that green line? If you flip the shaded one over, it matches up. If you flip the non-shaded one, it matches up. Does it have rotational symmetry? If you took this and turned it 180 degrees, would it match up? No. So for each of these ones, I want you to first think on your own. Does it have rotational symmetry? Does it have line symmetry? The answer to this one? Yes. How many lines of symmetry? 2. It has horizontal and vertical. If you draw a line through here and flipped it over, it would match up. If you drew a line right in between them and flipped them over, they would match up. In this case, we're not worrying about shaded and not shaded, okay? So the vertical one, if you flipped it over, the shading and not shading wouldn't match up. But it's just to show where one object started and the other one went to. This one also has rotational symmetry. Remember, with rotational symmetry, we had an order and an angle. To find the order, you can trace your original objects. And if you rotate them and they match up, bing! See how they matched up one time around, and then you count a second time around when you get back to the beginning. So we would say the order is 2. The way that we count the order, again, I'll show it here. You start it, you rotate it, that hits once, rotate it again, back to the top is twice. So you count the one time that you touched the first time, and then the second time when you get back to the beginning. The formula to find the angle is always 360 divided by the order. So in our case, it's going to be 360 divided by 2. Our angle is 180 degrees. Okay, next one, 10-second head start. Now on the test, you're going to be allowed to use the mirrors to check. This one has no line symmetry. If you put your line down the middle and flipped it over, it wouldn't match up. If you put a diagonal one and tried it and looked, it wouldn't match up. To check if this has rotational symmetry, again, I would trace it out. Trace that box out, trace that box out. Oh, there we go. Take it, rotate it. Bing! They match up once and match up again there. So the order is 2. And the angle? Is 180 degrees. Ross, we're on the second page. Another one. Again, try it first on your own. For line symmetry, does it have line symmetry? Yes. How many lines of symmetry? 4 of them. Okay, you would have 1, 2, horizontal, vertical, 3, 4. Line symmetry, there are 4 of them. Check our rotational symmetry. Count them the times they match up. 1, 2, 3, 4. So the order is 4. What's the angle if the order is 4? 90 degrees. Awesome. Our next example. Okay. So, draw the following rectangle. When points are labeled, do you know that points have an x coordinate and a y coordinate? You remember that from? And the x is always, your x-axis is always horizontal. Your y-axis is always vertical. So when I have the point -1, 1, that means I go -1 in the x direction, 1 in the y direction, label that point -1, 1. 3, 1 would go 3 in the x direction, 1 in the y direction, label that point 3, 1. 3, 0, and -1, 0. And it makes a rectangle. And we can label all of those points.
It's Halloween. Halloween only comes once a year. We'll only be in your grade 9 class once a year.
Yeah.
I will pass this class if we do a Halloween.
All right, we'll get there.
I promise you that. You have my, I will write it down.
Okay. So what we want to do, and for a test, on a test, you would have tracing paper for this. Do you know the origin is the point 0, 0? So you would trace this out, and what I would do is I would label this point, which I've done in red. I would hold my pen on that point, take my tracing paper, and turn it 180 degrees. If you did that, That's the shape that you would get. The same rectangle rotated 180 degrees. As a result, obviously, because we rotated it, it has rotational symmetry. That's obvious, with an order of 2 and an angle of 180 degrees. But when we look at our final answer here, oh, I'm a little bit off on my drawing. It should have ended right there. This one has no line symmetry. Same rectangle. Okay, we'll redraw that same rectangle on the next one. And if you reflected that in the x-axis, you would get this rectangle. As a result, it has line symmetry. How many? Two. Vertical and horizontal. Could you rotate this and make it match up? Yes. It has rotation symmetry, an order of 2 and an angle of 180 degrees. One more example to go. Maybe.
I'll pass.
And the last one. If you took the original shape and you took it, and it says you take the original shape and you slide it or translate it 4 units to the right. 1, 2, 3, 4, and 1 unit down. As a result, you might think there's line symmetry, like reflecting over a diagonal line. If you would check it with your mirror, it doesn't actually work out. There is no line symmetry. But if you traced out this whole shape, and did rotation symmetry, it matches up once there and once there again. So it does have rotational symmetry. It has an order of 2 and an angle of 180 degrees. Oh, here's the warm-up. Car logos. Okay. This is the warm-up to get to the Kahoot. Your first Kahoot will be on car logos. So I'll give you one. What kind of car? Volkswagen. There it is. And can you see that it has line symmetry, but no rotational symmetry? Okay, here's the next one. That is BMW. Does it have any symmetry? Yes, it does. Woohoo! It has rotational symmetry and line symmetry, 2 of them. All right. Mercedes, good job. Rotational symmetry? order of 3, angle of 120, and line of symmetry.
I'm getting a Mercedes.
There it is. 3 lines of symmetry. No. Oh, nobody got this one. That's the old Acura.
Drive those things.
There we go. 1 line of symmetry. No rotational. How about this one?
That thing that the police cars in cars.
Pontiac. 1 line of symmetry there. Rotation, none. Okay,
Gee, I wonder what this is. GMC.
it's a Dodge.
Are you dumb?
1 line of symmetry there.
Sorry, we don't know.
Kind of interesting to see how many, like a lot of logos use symmetry. No rotational. Toyota, good job.
Good job. Good job, Dante.
Lexus. No, that's another one with an A.
I'm waiting for the beamer.
Infinity.
It looks like
1 line of symmetry, no rotational. Okay, Cadillac.
Why would it be called Infinity but then not have the Infinity symbol?
I don't know. The interesting thing about the Cadillac is that it's really, really close to having line symmetry, but it doesn't. It has, they're kind of creative because if you just look at the silver, it has line symmetry, and the inside has rotational symmetry, but when you put it all together, it has no symmetry. How could you change it? You could slide this one, switch these colors to make it work. Ooh, tough one. Daewoo.
Never. That's definitely a Chinese car. Never heard of that. Definitely a Chinese car.
Okay. I'm going to give you hard ones. So these ones, now you have to know these ones for the Kahoot. These are the easy ones. Nice. No symmetry.
Honda.
Good job. 1 line of symmetry.
Audi.
Good job. It rotates.
Yeah, Olympics.
And the Olympic car. 2 lines of symmetry.
Mercedes.
Nope.
Mazda.
Mazda, good job.
Chevrolet.
It has rotational, but no line symmetry. See how the line symmetry almost makes you think there's one down here, but the points wouldn't match up when it flips across. No.
Hyundai.
Hyundai. It has rotational symmetry, but no line symmetry. Starfish car, yes. No, it's a Chrysler. There, you got it. It has rotational symmetry of 5, angle of 72, and 1, 2, 3, 4, 5 lines of symmetry.
No, I know this. Oh, boy, no. Is that with an M or something? Oh, Mitsubishi.
Mitsubishi.
That's what I was gonna say. That sounds like a teacher.
3 lines of symmetry.
Rolls-Royce.
Rolls-Royce.
Started to start.
No symmetry, but it has a translation.